Good afternoon, ladies and gentlemen. Welcome to Algebra 2 Honors. Today we're going to talk some about graphical transformations. Does anybody have any idea what is the meaning of graphical transformations? Okay, rotation would be a type of transformation. What else? And actually, rotating is the only one we're not going to do today. Okay, reflection, right? In which ways can we reflect?
Up and down.
Up and down, which would be like a vertical, and
horizontal.
Horizontal, right? So we're going to examine those two, thank you. And what else can we do with it as a translation? Translation. The translation would be moving either left and right or up and down. Okay, and there's one more thing we're going to examine today, which is what other thing can you think of?
Rotation.
Dilation.
Okay, now you mentioned, it's dilation, but in Algebra 2 language, we don't call it exactly dilation. We call it a vertical stretch or compression,
Oh, that's right, I remember that now.
or a horizontal stretch or compression, which isn't exactly the same as a dilation, but still has a similar, because we multiply. By a dilation, you multiply by a what? What do you multiply by? What do we call the thing you multiply by? Starts with a F.
Fraction.
No. No. Factor. Okay, factor is what you, so factor is what you multiply by, right? So we're going to stretch and compress, we're going to vertically stretch and compress by a factor of something, which is the number that you multiply by. So again, so you guys pretty much got it. So we're going to examine today, let me get my right size pen that I want.
Yeah.
Can you have it? No.
Okay, so we're going to go ahead and we're going to look at translations. We're going to look at reflections. We're going to look at stretches and shrinks or compressions. And so those are the main things we're going to look at. And I'm going to tell you when to start writing notes. All right? So we have this function, f of x equals 1/4 x squared minus 4. What kind of a function do we call this?
A quadratic.
A quadratic function, okay? Quadratic function, which is from the family of polynomial functions. Thank you, Connor. And what we're going to do is we're going to horizontally translate the graph of this function. And we horizontally translate, we're moving the graph of the function left and right. And we're going to hone in on this x, and we're going to replace this x with h. So h is what moves graph left and right. Left, I'm going to put left slash right. Okay? So it's the value of this h. And this h in the place of this equation here is something we're going to see repeatedly during our course this year. Not only for quadratic functions, but for virtually all other types of functions I can think of that we'll cover this year. Okay, so shifts to the left or to the right. Now, we're going to have you make a prediction. If we go ahead and let h equal 3, so that we replace h with 3 and have 1/4 of this x minus 3, which way do you think this curve is going to shift? To left, 3 units? Okay, let's take a look at what happens. Well, actually, minus 3 shifts the curve to the right 3 units. Okay, well, Connor asked the question why. We're going to get into that later, probably in this course and pre-calculus next year also. We're going to explain why. I don't want to explain right now, other than to explain that this is really a counterintuitive thing, isn't it? Because Ben and somebody else says, oh, shift to the left, right? And that's the first thing I would think. We talk about intuitive. What is something that is intuitive or intuition? What is that?
First thing that comes to mind.
Okay, Ben just said, and I'm repeating because just to get amplified. Ben says the first thing that comes to mind. Yeah, the initial feeling or impression. Someone else in, I think it was Chloe in second period said the kind of your gut feel for it, right? And yeah, that's what intuition is. But this is kind of counterintuitive, isn't it? Well, what I want to do is, this is the very first thing I mentioned today out of design, because I wanted to have your freshest attention span on this part of the lesson today. Because of all the things that we are looking at today, this is the one that is the least intuitive. And when we have the Merry Algebra 2 Christmas song, there's a part of it that goes, x plus moves to the left and x minus to the right. Okay, so that's one of the things. And it's in the song, and so you're going to get used to it. So what is not intuitive to you now is going to be kind of inbred into your mathematical education. That'll be easy for you to figure out. And how could you figure it out anyway if you didn't know that or forgot this? What could you use?
Calculator.
You could use your calculator and verify your intuition, right? So I hope you get in the habit of doing that. But I always like you to have to think first before you try your calculator, if it's possible to do so. That way you can activate your mind, all right? Yeah, Connor, we're going to go into y later on, and then if we go ahead and say 1x plus 4 here, we would shift 4 units to the left, all right? And did anybody do that in their calculator to check while I was talking? You just believe me, huh?
Yes.
Okay, all right.
We had that with Tristan in your shop.
All right. Don't always believe me, all right? Vertical translation. Now, vertical translation is fashioned by taking this last value outside here, this -4, and that's going to move things up and down. This thing here at the end of the function that's kind of separate is, we're going to later call it the constant k. So this k, now the h is the one inside here that moves the function, graph the function left and right. The k on the outside, either plus or minus, is going to move the function up and down, the graph the function. So adding to it makes it larger. So if we take this -4 plus 5, what are we going to get? 1. And what is that going to look like? Well, it's going to look like this. Okay? So this is what we call k. And what else, and then if we go ahead and take k equals -6, we come down here. What else could you call these things right here? In algebra language, the what? You can call these y-intercepts. So the way the thing is written here, the k is the y. Now, as it turns out in vertex form, that's not always going to be the case, because if we have this shifted over, it wouldn't be exactly the same. But in this form here, where you have symmetry about the y-axis, and what kind of symmetry did we call this last week? Yeah, we called this even symmetry. Okay, and we're going to talk about that a little more. Do you remember that from last week? Last week was a long time ago, right?
It felt like it didn't.
Felt like it, yeah. Okay, now what I want you to do is make a note of this thing right here, And this is the vertex form of like a quadratic function. And I'm going to try to do a little rewriting here. I had a little trouble people reading. The thing may not necessarily reflect about the x-axis, but will be opening downward. So it may not exactly reflect about x-axis, but I will just say, I'll change that to opens downward. I'll say that parabola opens downward because that's technically more correct.
Thanks for the eraser pen.
What'd you say?
I said thanks for the eraser pen.
Okay. Okay, if A is negative, parabola opens downward, which may or may not reflect about the x-axis.
I just I already finished it.
All right. So let's go on here. For a horizontal reflection, we have this function here, f of x equals 1/4 x cubed minus 4. And this is what that function looks like, just like this, right? And if we go ahead and change this x, what do you think is going to cause that horizontal reflection about the y-axis? What kind of operation would that be? What would you have to do that function? Well, I will show you. What happens is if we change this x to a negative x inside parentheses like this, what that's going to do is going to take the graph and reflect that graph about the y-axis. All right? And what kind of symmetry do we, what kind of function is this one right here?
Or quadratic?
Yeah, what it is, if we had one function, we would call this even symmetry, but it's not really that. Because what you would do is this thing really has neither odd nor even symmetry, but if we had it out like this, right, then we could rotate about the origin, right? But we can't exactly do that with this one here, can we? So that's why this thing really has neither odd nor even symmetry, okay? Next, vertical reflection. What are we going to do to have a vertical reflection? What kind of operation do you think? Okay.
Before positive.
What you're going to do is you would multiply the whole function by -1. And when you do that, you're going to get this. Okay. So it takes whatever positive value was up here and makes that value negative down here. Or these negative values here and makes them positive up here. So this would be an example of a vertical reflection. Okay. Does that halfway make sense? Okay. Next, inverse reflection. We're going to cover this later, either this year in Algebra 2 or next year in pre-calculus. But these are graphics I prepared for my pre-calculus classes. So we're just going to go to horizontal stretch. So we skipped over some things quickly here. Okay. Now, what are we going to do to horizontally stretch this graph here, do you think? What would we do? Do you have an idea of what we would do for that?
Multiply.
Multiply by what? I'll show you. What it is, if we have this 1/4 x squared minus 4, right? If we, horizontal stretch occurs when we multiply this factor by a number less than 1. So if we take, for instance, this 1/4 and multiply 1/4 by 1/2, what would we get? We would get 1/8. And so f of x equals 1/8 x squared minus 4 will be like this one in blue compared to the original one in red. So that's what a horizontal stretch looks like. Now a horizontal squeeze or compression. What do you think would cause this function here to horizontally squeeze or compress? What do you think?
Has to be greater than 1 to be a horizontal stretch?
To be a horizontal compression. That's what you meant to say, right? Yeah, so if we go ahead and multiply by a number greater than 1, this is what that horizontal squeeze or compression would look like compared to the original red one here, right? Okay. Now we're going to talk about vertical stretches and compressions. And what I like to do in the course is really to emphasize talking more about vertical stretches and compressions. And I hope you can understand that a vertical stretch looks kind of like a horizontal compression, doesn't it? So if we vertically stretch, in this case, when we multiply by 2, what do we call this value of 2? What do we call that thing?
A
We call it a factor. So for this one, we would say vertically stretch by a factor of 2. By factor equal to 2. And when we do that, what we get is we end up with 1/2 x squared minus 8. And when you graph that function, that's what it looks like. Can you see that's what it does? It's like you take that red one and just stretch by a factor of 2, and that's what the thing looks like. Okay? And if you put that in your calculator, that's exactly what you'd see. And also, if you take, for a vertical squeeze or compression, what would you multiply this entire function by? Well, you multiply by a factor of less than 1. In this case, if we multiply the whole function by 1/2, we would get 1/8 x squared minus 2, which when graphed would look like this blue one here. Okay? Now, in the next slide here, I'm going to want you to take notes and complete a table. There's a table that has this kind of a summary of everything we've gone over today. So the next slide is going to be that. So I want you to take a few minutes creating that table. Now I want you to replicate this table, except I don't want you to do this last row down here. Okay, don't do the inverse function, but do everything else. So you'll have sort of like a guide of these things. All right? So if you'd work on that, I'd appreciate it. Ben, Emma told me about the piñata there for you. Did she make that for you?
Yeah.
It was really nice. So Emma to do that.
Yeah, Ben got all the rules. cubed on the algebra?
Yeah, the bottom one there is x cubed, yeah. Okay. All right, and if you're not quite done, you can copy out with somebody else. Want to go on and start working on a few of these problems today. And we probably are not going to be able to get through all these today. In fact, I know we're not. So let's just we might look at problems 1 through 6 for the remainder of the day. And so for these exercises here, write g of x in terms of f of x after performing the given transformation of the graph of f of x. And so if we take this, I'm going to just go ahead and overwrite the arc here. So if we overwrite the arc, that's kind of what it would look like, right? And what would be a transformation to the left? Well, it would be like this, right? 1, 2, 3. And how would we articulate in the language of algebra that translation? It's going to be g of x is equal to f of what? X what? Yeah, so Gabby, is that right, Gabby? Yeah, so that's going to be, see, f of x plus 3. And again, you can, most of these test with your, in fact, all of them really test with your calculator to make sure that's the case. So you could take a parabola and then put x plus 3, you'd see this thing shift to the left, all right? Okay, and then if we have number 2, in this case, translate the graph of f of x up 2 units. So we move this graph up 2 units, and that would look something like this, right? 1, 2. So this one's going to be g of x is equal to f of x. And what do we have to do to this function here? Yeah, so we'll put plus 2, in this case, on the outside of the parentheses here, okay? Now, on 3 and 4, 3 and 4 are kind of similar to 1 and 2, so I want you to work on those briefly, and we'll go over them in a couple minutes, okay? All right, so for number 3, we're shifting to the right 4 units. So what would we say that g of x is equal to? X minus 4, okay, so Gabby says that. Does that seem right? Everybody agree with that? Okay, good, that looks good. And next we have the same looking type of function here. And we're going to translate down 3 units. What is that going to be?
G of x is equals f of x, close parentheses, f of x minus 3. Wait, yeah, minus 3.
Minus 3, okay. So there we have 3 and 4. All right? Let's go to number 5 and 6. Stretch the graph of f of x horizontally by a factor of 3. What is that going to look like? Well, by a factor of 3, we have to multiply this -2 by 2, 3. So the thing is going to look something like this, right? So I didn't draw it exactly perfectly, but you get the idea, right? We're maintaining our y-intercept, but just horizontally stretching. What algebraic operation did we have to do to make this happen? Not as intuitive here, okay? What do you think we have to multiply by here?
3.
Well, you think it would be 3, but actually it's going to be 1/3.
Oh.
Okay. That's what's going to make this kind of horizontal stretch.
No.
Okay.
You got it on camera too.
Now, and then this last one, we vertically stretch. And when I say the last one, we're going to be talking about the last one that we go over today. So vertically stretched, this thing is going to look like this. And what would we do to this function here? G of x is equal to, what would we do to vertically stretch by a factor of 2? Okay, what you would do is you'd multiply it by 2. So it would be 2 times f of x, the whole thing. And what I did is I put this in a calculator, okay, and graphed. This is what the original looks like. In fact, I'm going to go zoom square. Okay, that's what it looks like. And if we stretch by a factor of 2, let's multiply this by 2. What is that going to look like? See? Vertical stretch. So we're going to leave it right there. Make sure you have tomorrow we'll finish this soon.